So agenda. So for today's webinar, our aim is introduce you to our approach to audio and video competitive benchmarking, and we will cover 4 main points. We'll look at overview on what is it, terminology also very quick, and what products are covered, and what is the essence of processes underneath and outcomes. And then we will look into why aspect and how companies can benefit from it. And then we will touch on technical details and cover how we do this part. And next, there will be part on reporting approach and how we analyze the data, and Q&A in the end. But also, if you have any question, please write it in the Q&A section. And so if you press more, and so there is a Q&A option there, and we will answer them towards the end. And as for overview, so as for benchmarking definition, so we say it's a process of evaluating performance of a product against certain criteria. It can be other software or can be other specific standards. And if we talk about audio and video performance benchmarking, it primarily analyzes the changes in quality and other factors through time. Also helps to compare multiple similar products. And benchmarking also could be done once in a while or in ongoing matter, for example, in monthly iterations. And on purpose, so the main purpose is identifying strengths and areas to improve compared to market leaders to make informed, basically, engineering and business decisions. And these are the products and industries where we see this type of benchmarking is useful, starting from communication platforms as service, going to streaming and short-form videos, and usually covering all the different industries, starting from social networks down to hardware and education. I actually have another poll to ask is, I want to see what products and industry you represent. You should have this drop-down choice appearing now in polls. Music while you answer. Okay, not to delay anymore. Music is off, and yeah, I see most of folks are from video conferencing and SDK and short form videos. But yeah, it's so yeah, thanks for answering. Let's go to next. And on the core, what is the core essence of services? And so I want to go back to how it actually started. We set a goal in TestDevLab to create a laboratory to be able to measure audio and video products, and we decided to come up with a comprehensive approach for these solutions. And we started already earlier than 2019, but especially in 2019, we started to invest heavily in building dedicated laboratories to simulate end user behavior and all the different environments. And we concentrated on specialized hardware and software, stable and isolated network, automating processes, reviewing and improving them, and creating strict procedures and training our team. Also, we concentrated on taking in account all the different variety of scenarios found in audio video products, such as screen share or echo cancellation, noise suppression, virtual background testing, which came up a bit later. So yeah, that's the core essence of it. And as an outcome, we produce reports that have objective metrics pinpointing application performance. And for the widest audiences, so to cover basically anyone can understand the outcomes, multiple metrics can be combined, such as in this graph on the right, to produce one single score for a very easy comparison. So even my grandmother will understand this graph, but I haven't actually shown this graph yet, but I might show it to her tomorrow. Papa and Eva and Geertz, would your parents and grandparents understand this graph? What do you think?
I think so.
Yeah, if it's one number, it's much easier to understand what is happening.
Yeah, just in case for audience, Eva and Geertz did know about this part. So yeah, it wasn't rehearsed. Okay, and so now going to the why part and giving mic to Geertz.
All right. Yeah, so let's cover why you would want to do it, what do you get out of it, and how does it actually work. So the first and most important question, you always want to start with why. Why do you want to do benchmarking? And here, the number one reason to think about is that when you have a communications product, either a platform or an application that involves audio and video, it is easy to get it to work. It's very hard to get it to work well. And there's two dimensions to the well part. One is just different scenarios at a single point in time. So, two participants versus multiple, various network conditions, cross-browser, et cetera. And then more importantly, also over time. Things change over time, and you want to sort of repeatedly and continuously double check how your application is performing as time goes on. So that's kind of the most important reason. As also, as your user base grows, there are load considerations. People have very high sort of baseline of expectations these days with communications applications. Even if you don't change your own application necessarily, the environment around you still does change. For example, new versions of operating systems, new versions of browsers, new devices come onto the market, and so forth. And so all of those things might still affect the performance of your application. And so you do want to do your benchmarking periodically. And lastly, but last but not least, your competition is also not asleep, and they're making changes, they're improving their applications. So you always want to kind of go back and double check how your application is performing relative to the rest of the field. So those are kind of the main reasons why benchmarking is important. Now, what do you get out of benchmarking? Again, number one, customer is always number one. You want to have happy users. So ensuring that your users have the best user experience is obviously one of the reasons to do benchmarking and to redo it periodically. Also, of course, it allows you to detect issues, and both performance issues and bugs early, and the earlier you catch them, the easier and less costly it is to address them. You get to be prepared for various user scenarios. You get to make informed decisions about how to allocate your development resources. Doing the benchmarking will kind of illustrate where you're doing well, where you have some improvement to do, and so you can direct resources towards those areas. And again, last but not least, competitively, you get competitive intelligence about the performance of your product and what are your strengths, what are your weaknesses, and that will allow you to strategically position your product in the market and highlight your strengths while you address the weaknesses. So that's that. Those are the things that you get out of benchmarking. And now let's go to how it works. So when you engage Test-Dev Lab for your benchmarking purposes, you get a whole lot of things. So number one, as experts, we have certain scenarios that we obviously recommend, but every customer is different, and so you get a custom set of tailored scenarios that get tested depending on your particular needs and your particular application. You have a dedicated team of engineers working on the benchmarking. There are dedicated audio video specific labs with equipment. The process has a strict methodology. The importance there is that ensures that the process is repeatable and the results are comparable over time. So when you do your benchmarking this quarter versus next quarter, next year, you're running the same process, you're getting the same measurements, and you can compare the results. Very importantly, there's specialized hardware and internally developed specialized software to perform these tests. There's both manual and automated processes. The important point on this is that yes, you want to automate as much as possible, but no more. There are always certain corner cases that you can't automate necessarily, and so but you do want to check them. So you have manual interventions. There is a specialized network testing capability with fine-grained controls around latency and packet loss and jitter to simulate various network conditions in your application. More than 4,000 physical specific devices. This is very important for mobile testing, but there's also desktop items, tablets, etc. And then as these tests are run, you actually get a pretty thorough deep dive into the overall experience that your users would face. And wherever we find issues, we also kind of dig into it and have suggestions as to why that might be going on. So, and those are all highlighted to you in the reports. So that's just a high level overview of how it works and what you get out of it and why you would do it in the first place.
Yeah, and from those key features, let's dive into a more technical ones in a bit more detail. To overall summarize all those details, we have a dedicated custom created audio and video testing laboratory, which is a black box environment, which is highly controlled from different aspects that come into play when we are doing the tests. We use physical devices, so we opt to use physical devices to ensure the best representation of the realistic scenario when the audio and video software would be used. Either it's a calling application, conference call, or potentially just the video streaming platform. We have knowledgeable engineers with expertise in different audio and video areas that operate the setup either manually or in automated fashion. Depending on what the project is for, depending on what the goals are, they might need a bit of more subjective input from the manual testing side, or they just want the objective evaluation where automated testing would be a better way to do that. And we have aligned and very thought through process from the test execution to the analytics stage, where we analyze the data in multiple stages and ensure that the physical setup actually represents and gives us the data that we can then share with insightful visualizations and also comments on how to either improve the product or where the product stands out the most. To ensure different environments and also controlled environment, the biggest part of the audio video services that we have is dedicated network infrastructure. We have this network infrastructure in all of our office premises, and we are creating sort of a net of different devices cooperating with each other, however, having a separate network access. So we have a dedicated network for each testing laboratory for audio and video tests. So we have a hypervisor, which is then splitting into multiple access points, and each device within the testing laboratory has their own access point. It allows us to have a full control of the network environment and also environment within one laboratory without interfering with other tests happening within the office premises or with different laboratories that are somewhere nearby, as well as it also allows us to do the repeatable infrastructure, repeatable setup, and we can do the tests in the similar environment in multiple times during some sort of time period or during one project or during multiple executions. It also allows us to shape the network and ensure different network environments for more interesting testing opportunities and helping us to test how the product would perform in various network conditions. Either it's a good home Wi-Fi or, for example, country road drive somewhere in the middle of nowhere. And such infrastructure help us to ensure bandwidth limitations, different packet loss scenarios. We can change also jitter or create more complex scenarios that combine all of them together or are variable over time. And this is actually the inside of our black box laboratory. And you can see all the hardware that is going into the black box and is not visible maybe outside to the person who's not operating it. So the reason why we have a black box is because you can see in the hardware setup, there's a monitor which is used for the video playback to ensure the video media stream during the audio and video software use. And the black box environment helps us to ensure that we have controlled lighting setting and we are fully in control of how the image looks in the call or different type of video experience as well. We also have a sender and receiver device, which are usually devices under test that we observe and see their performance during the test. They can be mobile or desktop or even tablets if you wish to do so. And we also have some different other devices, for example, audio card, external webcam, and computers to ensure that we have a fully equipped laboratory and we can process and record audio, video, both from the device and also externally for video delay measurement. And also we have laptops to ensure that we can operate fully with the black box setup. If we look at the general AV testing process, it can be done in a similar manner. It can be adjusted to your needs, but generally the first step is the user. So basically either manual tester or a person who's operating the automated setup starts the test by interacting with different UI elements to actually start the call or start the streaming or different type of audio and video software functionality. Then we go to the capturing stage. So we kickstart the test and we ensure that we have screen capture and also external video capture to capture video for video metric processing. We also use the audio card and tags to ensure that we capture audio to ensure audio related metrics. And we also use TCP dump to ensure network capture through the router in other words, the access point that provides the network. And then once we gather all the raw data, we go into the analytics stage and we use different algorithms, either standardized or internally created to ensure detailed analytics and gather the metrics over time. So we use VQBox, which is internal tool to analyze test video and extract, for example, frame rate, video quality, and also video delay. We use Polka algorithm to analyze audio quality and also in parallel audio delay. And we use Wireshark or generally look at the data through the router as well to analyze network traces and network consumption on both ends of the call. And once we have all that, we have gathered all the results. And now the biggest part is to analyze it all. And to do so during the actual capturing, we can ensure raw data to and raw files to extract different types of metrics that are most suitable to the objectives of each project. And we use both industry standards and also in-house developed metrics to get the full package and ensure the full picture of the performance of the application under test. From the industry standard, for example, for video, we can use VMAF, which is industry standard full reference video quality assessment. We can ensure that we see what freezes happened during the test, or for example, frame rate or video delay. We also see the network consumption and packet size and packet rate, and also packet loss. So what happened during the call in terms of the packet loss. We can also do audio quality assessment using either Polka or Viscal algorithms. And as well, additionally, we can do performance testing on the side to ensure that we also capture CPU, memory usage, or battery usage during such tests. And in-house, we have developed also additional metrics that just sometimes give even fuller picture and more information on what has happened. For example, for video, it's VQTDL, which is non-reference video quality algorithm, or for example, brightness or blurriness, and how the video changes throughout different network environments as well. And for audio, from our side, such tools include ASCII-VIT, which is also audio quality assessment, or for example, speech key. And regarding the products, yeah, I will give a word to Nikolai so he can tell you more about that.
Okay, so yeah, one more part about technical descriptions is actually audio video products we have built. So during our work with audio video products testing and benchmarking, we have seen that there are some gaps that we need to fill, and we have R&D department who is helping us with those matters. And obviously, yeah, these are the big ones. There were hundreds of minor improvements that was made to scripts and our methodology, but we're not talking about these details here. So our main three babies are VQTDL, VQBox, and Tempero. And I have put Lodero as a fourth one as an extra because it's actually not an AV product. It's just we are using it also a lot in our benchmarking. But Lodero is actually web application for load and performance testing as a test the flap sister company. Going back to VQTDL, So it's actually a no reference algorithm based on deep learning. Tempera is our web platform where you can visualize the data and see the graphs. And VQBox is our, as Eva mentioned, our processing solution for using REST API, and it's our data processing system. So instead of manually working with data, we have built VQBox. And I'll go also briefly over each one. And as for VQTDL, let me play back the video as well. And so it's based on deep learning, and actually why we build it is because on the market, we have noticed that no reference algorithms that were available, including Brisk, as you see in the graph, it wasn't the best, and it actually needed a lot of double checking on the data, and we noticed we spend a lot of time there, and we started to think about building our own, and we actually built one, and probably it's the best no reference algorithm out there, and like in Carlsberg advertisement. So what can it do? It can handle videos with different resolutions, and it's quite adaptable to different scenarios. And from our data, when comparing with industry algorithms, Brisk, and also others, actually in background now, our R&D team is doing even more research and comparing to all the different no reference algorithms. But what we see is prediction values are much more stable and much closer to subjective evaluations. And also it handles very good changes of UI, and minor changes are not like doing heavy, are not bringing heavy difference in scores in a similar manner as for human. As for Tempera, it basically looks like this. It's a web portal where you could easily navigate through the audio video data, filter, customize, and you can also create different graphs. I mean, not create yourself, but every project is customizable, and if you have particular needs for particular graphs, that's also doable. Has secure access, and it's possible also to save the charts in different formats and download media files. As for VQBox, as I mentioned, yeah, it's our data processing system, which is used internally, as well as it's available as a software as a service too. And if you have audio and video files, you need to get metrics from, and perhaps you are doing it manually yourself or through crowdsource activities, then VQBox can handle and produce metrics out of media. And Lodero, this is our, as I mentioned, sister company for TestDevLab, and this is very helpful for us when application works with many participants, such as like we're here in Zoom webinars. When we need to bring loads of users, we can do it with Lodero. Highly versatile. You can specify for every user location, network condition, media parameters, like does it come in a meeting with a 1080p feed or 720, and also audio feed. Can be muted, could be something like a background noise embedded. And yeah, on the right is like how test participant is edited, and basically it's you can create a script like a write in a Java, or I think Python as well is covered, and basically yeah, like you automate UI interactions, and then user comes in. So some users also can so yeah, basically any scenario can be automated. User can be in a breakout rooms and etc. And that's all on the products, and now there is a part on report, and giving mic back to Girts and Eva.
All right, so after all this thorough benchmarking, what you get is a set of outputs, the results, the reports. And so they can be tailored to different audiences that you may have. You can, you can tailor them to management or specifically engineering. We can provide them in various formats, whether it's slides or PDFs. Nikolai mentioned the web portal, and we can also kind of pre-bake it into a blog post. And these can be either one-time benchmarking results, or ideally on some sort of a recurring basis, depending on your needs, weekly, monthly, quarterly, etc. And going to the next slide, in terms of features, what this allows you to, what you get out of it is obviously you understand your positioning in the market. Where do you sit relative to your peers and competitors? The team does a deep dive into the overall end user experience using the various metrics that we discussed. You get thorough reports with an analysis. So not only do you get the numbers, but you also kind of get the story behind the numbers. Our experts can suggest certain courses of action and improvements, and point out improvements, areas of improvement, and also sometimes how that might be achieved. So, and you get nice charts and graphs explaining all of this.
Okay, thank you. Before I also move to the next slide, where Eva would go a bit deeper, I just wanted to highlight here that, as mentioned earlier, different levels of analysis is made, and this is very, I think, straightforward, and also serves to wider audience, such as management, for example, when you can clearly compare your application to market leader in a manner where you can see in which scenarios you have gap and in which scenarios you are better, like a top table, and the bottom table also could have some data on a previous iteration, like in a gray line, and really pinpoints where you still have a critical gap and where gap is maybe not so big. So very, very, I think, easy to understand graphs. So, yeah, but to you.
Yeah. And to ensure the overall results that we have been talking about, there's actually a very thought through ongoing analytics pros behind the walls before the data actually goes into the reporting. So the first stage is manual data capture, where the testers actually have the ability and all the tools necessary to do the quick checkups into anomalies or issues that might have come up during the test. Most common cases to look into network consumption, as well as quick audio check. Of course, there are other validation processes to ensure that the setup is in order, but if we talk about the data specifically, then they are looking at the consumption and the audio quality already after the test has been done, to spot check in the quickest way some anomalies that might be point of interest for potential investigation, or just to ensure that everything is in order. And then we move to the second stage, which is processing captured data. So while we are processing and extracting the metrics, there is also the validation of raw data that we see, and also the overtime data that we can extract from the raw files. And what we're looking here is actually, again, some anomalies that couldn't be found in the first stage, and also some additional insights from the overall performance of the product through the time for specific scenarios. And then we move to the third stage, which is basically the reporting stage. Data makes it to the reports and into the average graphs and have a more aggregated form. And that allows us to actually see if the data is consistent and logical, and see the overall trends of the performance for different products under test. And this is the last time to check that actually we see the either expected behavior. If there's not an expected behavior, it is explained and investigated to ensure that everything is in order before it passes through to our clients. And as I mentioned, the aggregated form of it all is average data, and usually it's visualized in the graphs. And basically, the benefits of average data is that we and also the receiver of the report can see a bigger picture, an overall trend of performance for different products that have been under testing in different scenarios or different platforms, or in specific functionalities. This data is then analyzed to prepare some overall insights, so more of a trend insights, and we can communicate that specific application is outperforming others in one area. However, the client's product is outperforming in another area. And when that information is explained, then the receiver of the report can make needed decisions afterwards. And also, average data overall is more readable and more easily understandable to different technical levels of the receivers. So, for example, both management and maybe very technical engineering side will understand this sort of visualization as well. However, underneath that average data, we have something a bit more complex. So we have overtime data, which can also be visualized, which is also done for the validation, and also just going through processes on site before we actually see any anomalies and interesting findings in the performance. So it allows us to do very thorough analysis of performance of each application that was under test. It also allows us to spot maybe some interesting pinpoints, or actually also trends that happen within one call or between multiple tests for one application as well. And it cues us to see correlation between the data. So for example, behavior for one metric correlates with another metric, and it can be noticed and also reported. And I would like to show you some of the overtime graph examples and how potentially we might go through them, what we could see in them. But before we do so, I want us to be on the same page about how we read those graphs. So this is overtime data graph. We have a title representing the scenario and also the metric that is showcased in the graph. On the y-axis, we have metric and the numerical score of that metric that is possible. So we will see data fluctuate through those scores. And on the x-axis, we have time in the call. In this example, it's 3 minutes. We will have a 5-minute example, and also the network limitations that are changing over time or specifically mentioned ones. There are multiple application data within one graph, and the data that I'm about to show you is the real data from specific tests and specific time frame. So this is one of the I would say brighter examples of what could you see in such graphs. So this is video data over time, and on the top graph you can see frame rate over time, and on the bottom one you can see video quality over time. And this is the scenario between the two users. So it's a call, and we have a variable bandwidth starting from 4 megabits, then changing to 1 megabit per second, then to 500 kilobits, and then increasing in a similar pattern. And change happens every minute, so every 60 seconds. And here you can see in the frame rate graph, which is the one above, that there are two main spots and two main things. So first thing that we would notice is that on the first change, the application 4 is not really able to handle such a drastic decrease in the available bandwidth. So it decides to actually turn off the video before it actually can adapt to the change. And that's why there's a gap in the data, because the video is turned off, thus we cannot really evaluate the quality that is happening there. And another interesting thing is the one that is highlighted with the black square is that on the second change, actually, two applications, so application 1 and application 2, are dropping the frame rate to be able to maintain the video throughout the call on 500 kilobits per second. And on the bottom graph, you can see one big finding that we would see. So first of all of the applications are dropping the video quality on 500 kilobits per second. And basically that is done to optimize the performance and ensure that the call keeps going, even with a bit lower quality, but still maintaining somewhat stable frame rate. And another thing, when I talked about the correlation, so we can see that also the video quality data is not available for the fourth application just because the video was turned off for that first change. And why does it happen and how it correlates? And the biggest source for that information is usually overtime network data. And here you can see two main things. So on the top graph, you can see receiver bitrate over time. And basically, the highlighted area explains why the change, why during that change, the application 4 turned off the video. So before the call has started, there was 4 megabits per second available to actually fulfill the call and ensure that it's working in a stable manner. And application 4 actually on average would consume around 3.5 megabits per second in that scenario. And once the limitation dropped to 1 megabit, it was just too harsh of a drop, and it was below the needed bandwidth for consumption. So basically, because of that, the application found it too harsh of a setback in terms of the bandwidth, and they decided to optimize the call by dropping off the video and potentially maintaining the audio quality over the video. But then they have opportunity to recover, and they actually do, as we saw in the video graphs as well. And also from the center graph and looking at the overall consumption on both ends, we can see that application 2 and 3, which were ensuring the most stable frame rate as well in the graphs before, have also the most stable consumption out of all. They already start on 1 megabit, and that explains why the decrease in quality and the frame rate happen only on 5 kilobits per second, because that is the first limitation, which is above the needed bandwidth. So to summarize what we have discussed in this webinar today, TestDevelop provides a fully equipped audio and video testing laboratory that ensures not only objective evaluation with different sorts of metrics that can suit your objectives in the testing needs, but also have a fully controlled environment and network infrastructure that can ensure different kinds of simulations of network environments, and also can be repeated in different points of time. Audio and video benchmarking as a tool can boost competitive intelligence of your product, and in more detail can ensure that the performance is monitored and observed over time for different types of applications, and also ensures the comparable nature of the data and helps to make more informed decisions for future strategy planning. We have a thorough three-stage analytics and validation to ensure that our results are trustworthy and they are fully showing the real picture and real performance of the call. Any anomalies that we have are investigated and then prepared as detailed insights and additional information on the overall performance of product under test and its competitors. And our reports are very thought through, and we create different kinds of visuals in different formats that are suitable to whoever will be receiving that report and help to make strategic decisions or business decisions in terms of where to invest and what functionalities could be improved over time.
Yeah, thanks, Eva. And I want to add also that those reports are sometimes used very well as marketing materials to persuade your users that your app is very good and they should use it.
We actually also support those materials. So if there is a wish to do so, we can discuss and help with needed visuals and data representations.
Yeah, and the way we do it, we would never consider doing particular report like to and hold our testing procedures in a way to make one application to stand better. So it's always a neutral approach we take. Okay, and now we have several questions and not a lot of time until the end. Let's go for them. And first one is from anonymous attendee, and the question is, what were some of the biggest challenges we have overcome to make sure the data is trustworthy? I think I'll take this one quick. So I think most important is realization that there should be a validation stage. Validation meaning that it's not just automatic processes of automatic checks that would look into the data and compare it with actual video, but sanity checks also from the actual human who knows about audio and video products, know how what is the difference and what are the different video artifacts found, and what actually what makes the audio quality bad and what makes the video quality bad. And so actually having someone to spot check, I think this is the most important. And we have a couple of questions from Emil. So first one is about shutter on the phone camera. And just in case, Emil, if you would think that question is not fully answered, maybe you can also raise a hand and give additional info. So about how we prevent or minimize aliasing when we have 30 FPS source, but app only allows 24 or 16 FPS. Eva, would you like to take this one? I can also, I guess, try to answer.
I can try to partially answer. If you feel that you can pitch in, feel free to do so. So the most common case that we are noticing within the testing, like example of aliasing, is Moire pattern. I believe I put the name right. And this is usually dealt with considering the lighting control within the laboratory. So that helps a lot to prevent that, and also the brightness settings between the different devices help to avoid that. However, we have specialized algorithms that can read the frame rate um, every single second, even when the source is with a different frame range. But also, I guess the biggest point that I can share here is that we create a custom video for the test, so custom media that is suitable to the needs of the specific testing. And if, for example, applications are able to ensure only 24 frames per second, we create custom media that is representative of 24 frames per second. However, when we are looking at the historical data that we have, our tools are precise enough and showcase the realistic frame rate, even if the source is, for example, 30, but application caps it only up to 24 or 16, for example.
Yeah, I would also add that basically our approach it doesn't. It's replicating. It's actually like taking account end user experience, and if on your device you will have 5 FPS, whether because of device performance or that maximum allowed frame rate is 16, then in our measurements it will be decoded to 16 FPS. So in the metrics you will have exact FPS you have on the screen on the device under test. We already 1 minute past, but yeah, I'll start to answer next ones. So Emil also asked about a new codecs like Opus and with a Polka version 2.4, and that's exactly version we're using in our evaluations. Emil is asking, do we see a need to upgrade to version 3 or later? To quickly answer this, I would say that it starts to make sense because obviously version 3 Polka covers full range, and Polka version 2.4 covers super wideband. But from our test and from information on web, we still see that between Polka version 2.4 and version 3, there are super minimal changes. It will be in a region of 0.1, 0.2 maximum score. And still, if quality degrades, so what it really changes is when you are with a top equipment, when your microphone produces, because also if we are measuring speech, then usually human voice does not produce frequencies over 16 kilohertz, and only music works with this content. So I think for music it makes sense to start to look into Polka version 3, but I would already tell that the financial politics Opticom has with Polka is version 3. I don't think will be found very often right now with companies offering that. So I think we are still in a Polka 2.4 version. Some insights I have heard from industry that I don't know actually if it's true or not. I haven't seen any code, but that Netflix is working also on open source solution for audio full reference evaluation, like VMAP sort of for audio.
But also, I wanted to mention in regards those data changes. So Nikolai's mentioned 0.1 and 0.2. Just if anybody in the audience would like that information. So usually the MOS score is between 1 being very bad quality to 4.5 for narrow band and 4.75 for wide band. Being almost exactly the same as the original And that change of 0.1 and 0.2 is considered a natural fluctuation that can happen due to the nature of the setup, and it does not indicate noticeable quality changes. So that's why that change is not that I would say drastic for us to take the measure and change the versions.
And yeah, so we'll take one more minute and finish at 9:05. So, sorry, 9:05 Latvian time. Yeah, not to take more of your time. And one more from Emil about AI generated video and avatars. How we deal with audio video sync. So we measure separately. We measure separately audio sync and video sync, and actually when we work with our test videos, so we inject Aruco markers or QR markers in simple terms, and this way we can measure video delay, and with specifics like testing AI generate videos with and avatars. We would go with the same approach as we do. We'll still use AI generated video and apply markers on it, and then create a test video from it and measure video delay, measure audio delay, and calculate AV synchronization out of that. Hope it answers. And the last one is about from anonymous attendee about if client is based in India, can our company make sure that video product will work in that market? I'll give a word to you, Eva, but take an account, maybe you can answer in 20 seconds, because you have international projects also. So yeah, too.
Yeah, so basically the biggest part of it is if you have the specific statistics of your user base and how they have their network consumption within your application, we can use that information to ensure quite precise profiling and emulation of the network on our premises. And the second biggest part would be most probably that we would with your help or with our engineering help in that country, do a live profiling of specific scenario that you would like, either sitting in a cafe or in airport. We would record the network behavior and emulate a similar situation on our premises as well. Hopefully 20 seconds.
Yeah, thank you everyone who joined, and we'll be sending the recording of webinar later and the slides, and feel free to check the link on TestDevLab at the bottom, and speak to us on LinkedIn or in email if you will have more questions or would like to discuss something particular. So yeah, that's bye from me, and Gears.
Thanks,
Thank
all.
you for joining. Thank you. Bye.
Cheers.
Bye. Thank you.